Hey guys, welcome to my YouTube channel. My name is Bhanu Chandra and I'm studying in Sri Venkateshwara College of Engineering, Bengaluru. And I'm first year student into engineering, and this is my first sem video assignment. My USN is 23DS1758, and today we are going to talk about the subject chemistry for CSE stream in VTU University. Today's topic is polymers, and I'm going to teach you everything about polymers theory part, and I'm going to give you the formula for numericals. So let's begin. Um, Today's important topics are: first thing is numericals of molecular weight of polymers, and conducting polymers, conducting mechanism of polyacetylene, oxidative doping and reductive doping. And the third thing is the most important part of examination. It is an expected question from VTO examination, preparation of graphene oxide by Hammer's method. And the fourth topic is a very small topic, but it's very important for the examination point of view. Kevlar, its synthesis, properties, and applications. So let's start. So polymers are basically macromolecules consisting of a large number of repeated units called monomers. These monomers are small structures that are added in a chain pattern to form polymers. And polymers are basically of two types: addition polymers and condensation polymers. For addition polymers, they are type of polymers which are formed by repetitive addition of monomers having double or triple bond. Example of this type of polymers is ethylene polymerized into polyethylene. In addition polymerization, there is no byproduct is formed. The second type of polymers are condensation polymers. In this type of polymers, they are obtained by two or more bifunctional or trifunctional monomers are condensed together. In this type of polymerization, there is a small byproduct of acid or a water or any small group. So difference between addition and condensation polymerization is that in addition polymers a small byproduct is not formed, whereas in condensation polymers a small byproduct is formed. So moving on to next topic is numericals. There are two type of numericals for our stream. One is for calculating molecular weight of polymers. First type is number average molecular weight and weight average molecular weight. So starting with the first type, number average molecular weight, it is denoted by m suffix n bar. It is a mass obtained when total mass of the molecule of the sample is divided by total number of molecules, where n represents the number of molecules and m represents the mass of the given molecule. Second type of numerical is weight average molecular weight. It is denoted by m suffix w bar. It is the mass obtained when sum of all the products of total mass of a given molecule and their respective molecular mass is divided by total mass of the molecule, where in the formula n denotes the number of molecules and m denotes the mass of the given molecule. So the next topic is conducting polymers. The definition for conducting polymers is polymers which exhibit bulk of electric current, which means they allow the electric current to pass through them, is called conducting polymers. Example for conducting polymers is polyacetylene and polyaniline. Coming to the next topic, synthesis of polyacetylene. It was synthesized by using acetylene monomer in presence of Ziegler-Natta catalyst, where an acetylene monomer is linked together in a chain wave pattern. In n number of molecules are come together, they become polyacetylene. So the conducting mechanism of polyacetylene is a very important question which may appear in VTO examination. So it is synthesized by doping, in which charged species are introduced in organic polymer having pi backbone. There are two types of doping done in polyacetylene. One is oxidative doping and other one is reductive doping. Oxidative doping, it is done by using an oxidizing agent to create a positively charged site on the polymer backbone, in which electrons can come and accommodate the positively charged to balance the charge. Commonly used oxidizing agents are iodine vapor, iodine in carbon tetrachloride, which is CCl4. The mechanism is given in the figure. A polyacetylene is taken in which it is induced with electrons and iodine in carbon tetrachloride, which results in formation of a polaron with a free radical and a positive charge at one end of the polymer, and the release of I3 minus electrons. Again, it is induced in I2 and CCl4, where two types of polarons are induced in the polymer, so it is called as bipolaron. So then the polymer is rearranged, which looks like the final product, which is the final product of the polymer, which conducts electricity. The second type of doping is reductive doping. Here the polymer is partially reduced by reducing agent that creates a negative charged site on polymer backbone, which can be accommodated by the positively charged electrons, so it increases the conductivity of the polymer. The commonly used reducing agent in this experiment is sodium naphthalate in tetrahydrofuran. The mechanism is shown in the figure. Both the mechanism of reductive and oxidative doping are identical, so it is easy to remember. So the polymer is induced in sodium naphthalate in tetrahydrofuran, which forms a polaron with a free radical and a minus charge on one end of the polymer, which ejects Na plus protons, and again it is induced to sodium in naphthalate, which forms a bipolaron, which on rearranging gives a conducting polymer which conducts electric current. So the next is a very important topic for VTO examination point of view, which is graphene oxide. Graphene oxide is an allotrope of carbon of a singly layered carbon atoms that are bonded together in a repetitive pattern of hexagons. It is prepared using a method called Hammer's method, which involves various steps. So preparation of graphene oxide involves the following steps. So first step is take graphene of 2 grams and sodium nitrate of 2 grams and combined with sulfuric acid and stirred for 30 minutes. The resulting mixture is added KMnO4, which is potassium permanganate, and the solution is then ultrasonicated at 50 degrees Celsius for 2 hours. The following resulting mixture after ultrasonication is added with diionized water of 200 ml, which is nothing but distilled water, and hydrogen peroxide of 12 ml slowly to the above solution. The obtained resulting solution is washed with hydrochloric acid of 300 ml and 10% dilution. The obtained powder is then dried, which gives graphene oxide. So the following resultant of graphene oxide is then further subjected to reduction by titrating with sodium borohydrate, gives reduced graphene oxide. So this is the final product which is required by us. The structure of graphene, as you can see, which after oxidization looks something like this. To the next topic, it's a very important question in the examination point of view for VTU students. It may be in your final examination from this chapter. So Kevlar is an aromatic polyamide, which means it includes a amide linkage in its final polymer state. It is a fiber which is stronger than steel and it is very durable. It is synthesized by the reaction between paraphenyl diamine and terephthalate chloride. So this is terephthalate chloride and this one is paraphenyl diamine. So after polymerization, water is eliminated, which is a small byproduct. The final Kevlar looks something like this. So since there's a small byproduct, Kevlar is a condensation polymer. So these are some important properties and applications of Kevlar. So starting with the properties, it is strong than steel, it is crystalline and non-flammable, it has a very good corrosion resistance, which means it doesn't corrode easily and can be used for a long time. It has a very good chemical resistance. It has excellent force and tensile strength, which makes it unbreakable. And some applications of Kevlar are: it is used to make cars and bicycle tires. It is used to make boat hulls, which are used to tag the boat to the shore, and it is used in aerospace industry. It is used in manufacturing F1 cars, petrol tanks, and used in manufacturing bulletproof items like car windows, car hoods, glass, etc. It is also used in building marine turbines. So that's it for today, guys. Thank you for watching my video. If you have any doubts or any questions, you can comment down below. Make sure to like my video as it helps a lot, and subscribe to my channel for more content. Thank you for watching.